Welcome back. This is Mr. Greenstein's Geometry, and we're talking about Chapter 10, specifically Section 4, inscribed angles and polygons that are inscribed inside of circles. So the first thing is inscribed angle. What is an inscribed angle? Well, it's an angle whose vertex is on the circle, and then it radiates out chords to two places on the circle. So the inscribed angle is going to be from R to Q to P, where the vertex is on the circle. That's an inscribed angle. The intercepted arc is the arc that's on the other side of that angle. So I have RQP as my inscribed angle, and the intercepted arc is P up to R. That's the arc, intercepted arc. The central angle in this whole thing is ROP. And you can see that I have two different angles here. This one is much wider than this one. So they're not equal as far as their measure. The central angle, remember, is the same number or the same value as the arc angle. Therefore, the inscribed angle cannot be the same as the arc angle. Inscribed polygon. So an inscribed polygon is a polygon whose vertices all lie on the circle. So in this case I have a pentagon and all of the vertices lie on the circle. When I draw a circle around a polygon and it hits all the vertices, it's called a circumscribed circle. So here on the right hand side I have a circumscribed circle around a polygon. It hits all the vertices. And I have an inscribed polygon that's inside this circle. The inscribed angle theorem says this, and this is a very, very important theorem. It says that the measure of an inscribed angle is exactly 1/2 the measure of its intercepted arc. So here I have the angle ADB. That angle, notice that the vertex is on the circle, that angle is exactly 1/2 of the arc angle here from A to B. The inscribed angles of a circle theorem say that if two inscribed angles of a circle, so here I have an inscribed angle D and C, then it's going to be it's going to have the same intercepted arc, and if it has the same intercepted arc, that means that both of these angles are going to be the same. Here we have a problem where RST, RST, this angle here is intercepting this arc here. So when it intercepts this arc, that means that this angle here is going to be 1/2 120 or 60 degrees. SU, which is an arc, the angle, the inscribed angle is 40 degrees, therefore the intercepted arc is going to be twice that, or 80 degrees. In this problem, we have RS, the measure of RS, that's the intercepted arc, and I have an inscribed angle here of 31 degrees. Therefore, RS must be twice that, or 62 degrees. When I look at the angle STR, it is intercepting the same as this angle here. So then this angle must be 31 degrees, just like this angle down here. What can you say about the angle TSU? TSU. Well, look how it intercepts this arc here. And TRU, this angle, intercepts this arc here. Since it intercepts the same arc, then this angle and this angle must be congruent. So we've shown that this angle and this angle are congruent. These two angles are congruent. Then what we can say about this triangle up here and this triangle down here is that they are similar triangles by angle-angle similarity. The inscribed right triangle theorem says that if a right triangle is inscribed in a circle and the hypotenuse is a diameter, so here's the hypotenuse, is a diameter of the circle, then this must be a right angle because it's 90 degrees where the intercepted arc is 180 degrees. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle must be a right triangle. So whether I have a right angle and an inscribed angle, then I have a diameter, or I start out with a diameter and I have the inscribed angle here, that has to be a right angle. So now I have a right triangle. There's the diameter and the right angle. An inscribed quadrilateral theorem says that if I have a quadrilateral inscribed in a circle, then the opposite angles are supplementary. F and D would be supplementary, E and G. So why are they supplementary? Let's just take a look at F and D. D is an inscribed angle and it intercepts EG, the arc EG. If I look at the angle F, inscribed angle, it intercepts E to G this way. And if I add both of those together, I would get 360 degrees. So these two angles are going to be exactly half of that when I add them together. Therefore, they are supplementary. And here we have a couple problems here. I have a diameter and I have an inscribed angle, and the inscribed angle has to be exactly half of that. So if this is 180 degrees, then this must be 90-degree angle, and you can solve for x. When I look at part B over here, I can see that I have an inscribed polygon inside, and that says that a quadrilateral, and that means that this angle here, y, is going to be supplementary to 120. So there's supplementary angles. And the same thing with F and D, they're going to be supplementary angles, and you can compute y and z from there. We will talk about more of this in the next day of class.